CRAMOO2 Special Status Independent Resource Allocation. Quench 1.0 Stage 1 Critical Risk Assessment Middle East and African Desert Zone Infrastructure Protection. Lightning Interference Regulation, Sandstorm Electrostatic Mitigation Artificial Fulgurite Substrate Conditioning, HV Dump Tank Architecture Van Allen Depression Response, Ground Level Ozone Protocol. 1. Executive Summary, Plain Language. Desert zones in the Middle East and North Africa present 4 distinct electromagnetic and chemical hazards to Prometheus infrastructure that do not exist at the same severity in temperate or underground deployments. This document assesses all 4 and defines the mitigation protocol. 2. Threat environment, physics of each hazard. 2.1 Lightning HV surge, the impulse problem. Desert lightning differs from temperate lightning primarily in the extraordinary potential gradients that build in hot, dry, convectively active air masses. The Sahara, Arabian Peninsula, and Sahel regions experience convective available potential energy events that produce return-stroke-peak currents of 50 to 200 kA and channel voltages of 100 MV/1 GV, with energy delivery in the 1 to 100 microsecond range. The problem for surface infrastructure is not survivability of the strike itself, it is the conducted and radiated impulse that propagates through any conductive path in the structure. Prometheus surface installations present large area conductive networks that act as efficient lightning capture surfaces. The conventional solution, surge arresters and ground rods, fails at this energy level because the ground impedance of dry desert sand is too high to dissipate the stroke energy before it reaches equipment. The ground itself is the problem. Quench 1.0 solves this by replacing the high impedance desert substrate with a preconditioned low impedance fulgurite network. 2.2 Sandstorm Electrostatic, the slow charge problem. When quartz sand particles collide and slide against each other and against surfaces during a Haboob or Shamal wind event, triboelectric charge separation produces electric field gradients of 10 to 100 kV per meter at ground level, well above the 3 kV per meter breakdown field of dry air at sea level. Corona discharge begins continuously from any protrusion or conductor edge. Unlike lightning, sandstorm electrostatic is not a single impulse, it is sustained HV stress over hours. Infrastructure experiences continuous corona discharge causing ozone production and surface erosion. Accumulated surface charge on dielectric coatings that discharges unpredictably when a threshold is reached. Sand particle impact abrasion of any exposed surface combined with simultaneous electrical stress, a uniquely destructive combined loading. The Quench 1.0 response is to ensure all surface charge has a continuous, controlled low impedance path to the fulgurite dump tank network via a surface grounding mesh embedded in the infrastructure substrate, preventing charge accumulation from reaching breakdown threshold. 2.3 Van Allen Belt Depression, the Zarkova scenario. Professor Valentina Zarkova and co-authors have modeled solar activity using a superposition of 2 magnetic wave components originating in different layers of the solar interior. Their model predicts a period of significantly reduced solar activity beginning approximately 2020 to 2053, analogous to the Maunder minimum of 1645 to 1715, with solar magnetic flux reduced by up to 60% at minimum. The geophysical consequence relevant to Prometheus is the following chain of effects during a deep solar minimum. Reduced solar wind pressure allows the magnetosphere to compress inward. The magnetopause moves closer to Earth. Reduced magnetic field shielding allows higher galactic cosmic ray flux to penetrate to lower altitudes, for Bush decrease events become less effective at exclusion. Van Allen belt inner boundary descends, the slot region between inner and outer belt moves to lower L shells, meaning energetic particle flux reaches lower altitudes. Enhanced atmospheric ionization at lower altitudes increases atmospheric conductivity, lowers the effective ionospheric height, and modifies the Schumann resonance cavity, directly coupling to layer 4 of the Prometheus system. In extreme scenarios, the dipole field weakens sufficiently that the Van Allen belts are no longer stably confined, energetic particles precipitate to ground level over extended geographic regions. producing sustained plasma-to-ground coupling events far exceeding normal lightning parameters. For Prometheus desert infrastructure, this scenario means prolonged periods of elevated energetic particle flux at ground level, elevated ionospheric conductivity causing anomalous Schumann resonance behavior, and potentially catastrophic plasma-to-ground discharge events with energy levels exceeding normal lightning by orders of magnitude. This is the design basis extreme event for the QUENCH 1.0 architecture. 2.4 Ground-level ozone, the silent coating killer. Every corona discharge, lightning stroke, and plasma-to-ground coupling event produces ozone via the reaction. Ozone is a powerful oxidizing agent. It attacks natural and synthetic rubber elastomers, polymer coatings including silicone, PTFE, and polyurethane, exposed copper windings in coil arrays, adhesive bond lines in composite structures. This directly threatens the Prometheus bore wall lining and conveyor belt specifications, which rely on silicone and PTFE elastomeric composites. Critically, standard ozone resistance ratings for elastomers are tested at 50 ppb continuous exposure. Desert electrical storm events produce 100 to 500 ppb episodic peaks. Standard ratings are insufficient for this environment. Material specifications require mandatory revision. 3. QUENCH 1.0 architecture, the fulgurite dump tank. 3.1 Natural fulgurite, the proof of concept. A fulgurite is a natural glass tube formed when lightning strikes quartz-rich sand or soil. The lightning channel melts and fuses the surrounding quartz grains along its path, creating a hollow glass tube of amorphous silicon dioxide that is mechanically strong, chemically inert, electrically semiconductive along its surface, and thermally stable to greater than 1,700 degrees Celsius. Natural fulgurites up to 5 meters long and 8 centimeters diameter have been recovered from Saharan sand. The key physical insight is that a fulgurite represents a preformed, low-impedance discharge path through an otherwise high-impedance substrate. Lightning preferentially follows existing fulgurites in subsequent strikes, nature's own feed-forward discharge channel. QUENCH 1.0 manufactures this at engineering scale, in a controlled geometry, before any natural event occurs. 3.2 Artificial fulgurite piling, the QUENCH method. QUENCH 1.0 Stage 1 uses purpose-built HVDC impulse generators to drive controlled lightning analog discharge events into the undisturbed desert substrate beneath and surrounding Prometheus infrastructure. The process: HVDC impulse source, Mark's generator or similar impulse topology, 500 kV to 5 MV output, 1 to 100 Ka peak current, pulse width 1 to 10 milliseconds, energy per shot 50 to 500 megajoules depending on substrate depth target. This is within the range of existing high-voltage impulse test equipment scaled up to field deployment. Electrode geometry: steel rod electrodes driven to target depth before discharge. Rod spacing defines fulgurite network mesh density. Target: fulgurite tubes of 5 to 15 centimeters diameter, full electrode depth, branching naturally through the sand column. Network geometry: hexagonal close-pack grid beneath the infrastructure footprint, with electrode spacing of 3 to 8 meters. This creates an interconnected fulgurite network of known geometry and verified impedance, the dump tank volume. Dielectric shielded piling: post-fulgurite formation, HV-rated polymer sheath conductor rods are driven alongside each fulgurite column, bonded to the fulgurite surface. These provide the connection between the surface infrastructure and the subsurface dump tank. Verification: ground-penetrating radar and electrical impedance tomography confirm fulgurite network continuity and geometry before infrastructure construction begins. 3.3 Tesla hairpin circuit, the dump tank mechanism. The fulgurite network operates as a distributed volumetric capacitive resistive discharge network, analogous to Tesla's hairpin resonant transmission line experiments, but operating as a broadband energy dump rather than a resonant system. The physics: The critical design parameter is the dump tank's total energy absorption capacity before the substrate temperature exceeds the quartz melting point, at which point additional fulgurite formation occurs, self-extending the dump tank. This positive feedback is a feature, not a failure mode. Extreme events cause the fulgurite network to grow deeper and denser, permanently increasing system capacity. This is the central finding that makes Quench 1.0 viable. The substrate volume available beneath desert infrastructure provides an energy absorption capacity that dwarfs any credible natural electrical event, including Van Allen depression plasma to ground coupling scenarios. The dump tank does not need to be designed to survive, it needs to be designed to absorb. 4. Ground-level ozone mitigation protocol. Ground-level ozone produced by electrical discharge events requires a two-track mitigation approach. Active ozone management at the infrastructure level, and mandatory material specification upgrade for all desert zone Prometheus components. 4.1 Structural and coating specification updates, mandatory. The following specification changes are mandatory for all Prometheus components deployed in MENA desert zones. These changes do not affect the fundamental electromagnetic architecture, they are material substitutions within the existing design envelope. During extended electrical storm events or Van Allen depression windows, active ozone management protects enclosed infrastructure. Activated carbon filtration on all air intakes, removes on from ventilation air before it contacts enclosed equipment. Activated carbon degrades on with greater than 99% efficiency at concentrations up to 10,000 ppb. Catalytic ozone destructors at bore portal entries, destroys on in portal airflow before it enters the bore tube where elastomeric surfaces are present. On monitoring array, electrochemical on sensors at 100 meters intervals along surface infrastructure, networked to the Prometheus zone controller. Trigger threshold for elevated protection mode, on greater than 150 ppb sustained greater than 30 minutes. Antiozonant surface treatment, annual application of liquid antiozonant wax to all accessible elastomeric surfaces provides radical scavenging surface protection. 5. Van Allen Depression Response Protocol. The Zarkova Grand Minimum scenario represents the design basis extreme event for Quench 1.0. The following graduated response protocol defines infrastructure operating modes correlated to geomagnetic field strength and Van Allen belt position indicators. The following graduated response protocol defines infrastructure operating modes correlated to geomagnetic field strength and Van Allen belt position indicators. 6. Resolution Protocol, Quench RP001. The following action register defines the workstream to formally close CRAM002 and achieve sign-off. Actions are sequenced for Phase 1 closure. 7. Sign-off criteria and resource allocation. 7.1 Sign-off criteria. CRAM002 is formally closed when all of the following are met. (7.2) Independent resource allocation. Formal risk assessment sign-off Formal risk assessment sign-off CRAM002 QUENCH 1.0 Stage 1. I, Chris D. Seeley, inventor of the Prometheus platform, confirm that Quench 1.0 Stage 1 architecture, artificial fulgurite substrate preconditioning and distributed dump tank, is physically sound and addresses all 4 identified MENA desert zone hazards. The resolution protocol Quench RP001 is approved for execution as an independent workstream with the resource allocation defined in Section 7.2. Material specification update is classified as mandatory and blocks Formal risk assessment sign-off CRAM002 QUENCH 1.0 Stage 1. I, Chris D. Seeley, inventor of the Prometheus platform, confirm that Quench 1.0 Stage 1 architecture, artificial fulgurite substrate preconditioning and distributed dump tank, is physically sound and addresses all 4 identified MENA desert zone hazards. The resolution protocol Quench RP001 is approved for execution as an independent workstream with the resource allocation defined in Section 7.2. Material specification update is classified as mandatory and blocks desert zone deployment until signed off. The Van Allen depression is accepted as the design basis extreme event. The Black Alert level operational protocol is approved. The fulgurite network self-extension under ELE class events is recognized as a design success condition. CRAM002, Quench -1.0-S1, V1.0. 2026 Chris D. Seeley. All rights reserved. CRAM002 is a companion document to the Prometheus Hierarchy RPC Protocol 1.0 and PPT CRA001. Maintained under the same confidentiality and IP terms.